All right, the last section in chapter 10, we talk about volume and surface area. So volume is the amount of space a solid object takes, okay? So instead of us looking at just a square and finding area and perimeter, we're looking at three-dimensional objects. Okay, so like a box or something of that nature. And you'll often see all these little dotted lines inside here. So we're looking at something that's solid and three-dimensional here. So the formulas for your different volumes are on pages 110 and 111. So we have the boxes, which is similar to what I just drew. Pyramids, okay, so three-dimensional objects of that nature with a square on the bottom and a triangle on the top. A cylinder, a cone, which is like a right triangle revolving around itself, and then of course a sphere, which would be a solid circle. Okay, and units for volume are cubed. Okay, because these are three-dimensional objects. Your units, whatever unit you have on there, is going to be cubed. Okay, so I'm just going to look at a quick one from example 1 on page 111. And I'm just going to look at part B and part A. So I'm given a cube. Okay, so a three-dimensional object, okay, with centimeters there, 4 centimeters here, and 4 centimeters in height. Okay, now the volume of any kind of box type of thing, whether it be a rectangle or a cubic kind of thing, is this the multiplication of the depth, represented here, the width, and the height. In these cases, they're all the same. So I just multiply 4 times 4 times 4, and I go ahead and get 64. My units are centimeters, and they're cubed. Okay, so really easy to do. You're just following the formulas. Again, you don't necessarily will memorize any of these. Maybe you might do the cubes or the rectangles, but probably not some of the other ones. Okay, stick with example 1, and I'm going to go to number E. Okay, so this one is a cone. Okay, and cone here, for the cone, it's 1/3 r squared height and pi. Okay, so I have 1/3. They give me the radius on the inside here. The radius here is 4, and the height is 9, and our units are in meters for both of them. Okay, so I have my radius, which is 4, and I'm going to square it. My height is 9, and I have pi. All right, and you can go ahead and multiply all these together. I get 150 and 796, and I'm going to stop there. And they didn't ask for any units, but I'm going to go ahead and round it to a whole number. So we're looking at about 151 meters cubed. Because this 7's close enough here, it becomes an 8. I'm going to go ahead and just round it up to 151. All right. And that's go ahead, and that's a cone here. I'm going to do one more. All right, and this is example 4. And this is on page 113. Now I will not try to draw this, but what we have going on here is we have 2 different objects. Okay, we have a circle type of deal on the top. It looks like an ice cream cone, so it's almost like we have this idea here of a triangle shape and an ice cream cone on top, but we're talking three-dimensional here. Okay, so I need to go ahead and use my formula for the cone part of it. Okay, and my formula for the cone part of it is going to still be the 1/3 pi r squared h for that. And then I need to use the sphere, which is represented up here, which is 4/3 pi r cubed. Okay, so I need to use both those ideas here. Okay, so when I go ahead and get the volume of this, all right, I'm going to go ahead and look at two different shapes here. So I have my 1/3 pi r squared first. So I have 1/3 pi. My radius is, my diameter is 12. They're giving me my diameter, so I have to divide it by 2, so it's 6, and I have to square that. And then I have to multiply it by, now this is cool because what we really have here is half a sphere. We don't have a whole sphere. So my diameter is 6. Is 12. My radius is 6, right? But I only have actually half of a circle. So I'm going to go ahead and know that the height is going to be even half of this. Okay, and I'm going to use 3. Okay, so this isn't a full sphere. This is a half a sphere. It's like dividing by 2. All right, so the height is actually half of what it would normally be. Okay, so the height of this is going to be half of it. All right, we're going to go ahead and multiply that out, and I get 113.09, and I'm just going to leave it there. Now I have 4/3 pi r cubed. Okay, so that's 4/3 times, and my radius in this case is still 6. And I end up with 904 and 0.77. I'm going to go ahead and round these to whole numbers. So I'm going to use 113, and I'm going to use 905. And add those together, get 1,018 centimeters cubed, because my units were given in centimeters. Okay. And that's the basic idea of these. You won't see too many of these half shapes here where you have to go ahead and worry about that, which is why I did this particular example. Most of them, you're just plugging the numbers into the formula and going ahead and getting your result. The last part of this section is surface area. And for a lot of students, this seems to be a really hard one to go ahead and visualize. But what we do, and your formulas are on page 114, okay? And what surface area is, you want to think about gift wrapping, okay? And so you have this box that you're going to gift wrap. And you have 6 different sides to this box. So I'm going to go ahead and draw a box real quick. And I'm going to put the 3-dimensional into it. Okay, so when you're wrapping a gift, okay, you have to wrap 6 different sides. You have to wrap the top and the bottom, right? You have to also wrap 2 different sides. And then there's also a front and a back. Okay, so you have sides and then a top and bottom, and you have a front and a back. Okay, so if it's a cube, it's not going to make any difference, but if it's a rectangle, it seems to be a little bit more challenging. So I'm going to go ahead and do example 5 for this case here. And I'm going to go ahead and just label the one that I have. So I'm going to say this one's 10 yards. The front is going to be 16 yards. And then I have one more dimension here that I'm going to call 6 yards. This is obviously not drawn to scale here. Okay. And my formula for surface area for this particular one, because it's a rectangle, I have 2 times LW plus 2 times LH. I'll tell you guys what this means in a minute, plus 2 times WH. And what these two things represent is length and width, length and height, and width and height. So we're taking all our sides and putting them together, okay? I'm going to go ahead first and look at length times width, okay? Which would be like the front of my triangle. Okay, which would be 16 and 6. Okay, so I have two of those two things being multiplied together. That's our starting point. Now I want to look at length times height. Okay, or I just did length times height. So length times width. Length times width will be this little slanted like the bottoms here. And it's going to be 16 and my 10. And so I have two of those, and I have 16 and 10. Then I'm going to add that to my width and my height, which is this side piece here that I'm looking at. So I have a 10 here and a 6 here. Okay. And so I should have 10, 2 times 10 times 6. What you should also notate here is no number appears in all three. So I have the 16 twice, I have the 6 twice, and I have the 10 twice. That should totally occur. Okay. Now I just go ahead and do all the multiplication. So my first piece here, my 2 and 10 and 6, 2 and 10 and 6, okay, it's going to be 120. My 2 times 10 times 16 gives me 320. And my 2 times, whoops, did I mess up here? 2 times 6, oh, this one is 192, sorry. And then my 2 times 10 times 6 is going to give me my 120. And when I go ahead and add all those together, I get 632 yards. And this is still cubed. Okay, so this, even though it's surface area, it's area, we still go ahead and we're cubing it. All right, so I hope this helps out. And I will see you guys for the next chapter coming up pretty soon.